The dipole approximation is very important in this situation because in the atom field interaction, the dipole approximation, what is dipole approximation and how we can consider this in our system. So the dipole approximation assumes that an atom is small enough compared to the wavelength of light that the light electric field can be treated as uniform across the atom. So this uniform electric field is important. You know, the atom size in the 10 to the power minus 10 meter. And the wavelength, if we consider this the visible light, this is in a nanometer. So it means that the wavelength of light is large as compared to the atomic size. Then the point is how this atom interact with this applied field. Then this approximation is used, and here you can see if this atom interact with this light which has a wavelength like this, then here this atom is very small. In this small region, the electric field is uniform for this atom. So this point is clear that the atom, the electric field can be treated as uniform across the atom. So this is uniformly act with this field. So one point is clear. Another important point is this approximation focuses on the interaction between the electric dipole moment of the atom and the electric field of light. This is very important point, because if you see here, this the energy level of the atom, and this can generate some electric dipole, small electric field. This has some dipole, and this dipole some small electric field, and this small electric field can interact with this field. So this is the point that the dipole, electric dipole, interact with the field, and we must ignoring magnetic dipole moment because this is very small, and electric quadrupole. So ignoring this, and we can only consider the dipole. So this is an approximation. In this point I have written the electric quadrupole, the electric dipole makes a small electric field that interact with applied electric field. So this is the point. Actually, the electric field interact with the dipole of this system. So this is the approximation because we will ignore the magnetic dipole moment and electric quadrupole. So this is known as dipole approximation.